chemistry, we're in 9.7, which in my humble opinion should be the next TikTok fad, because what's 9.7? What is that known for? Anybody know? 9.7? It's a date. It's a very important date in world history. That is the day that I was born. So all you TikTokers out there, we need some kind of 9.7 phenomenon to really just get that going. It'll push that 6.7 right off the map, and we just start over with some kind of 9.7 stuff. But answers here on this 9.7. There's 5 simple types of reaction that we've been doing day after day after day, and we'll continue to do several more days. We have combination is the one we've known the most about, the longest. Decomposition is the brand newest one today to talk about. That's what's behind me on the board. There's single replacement, there's double replacement, and there's neutralization. So starting yesterday, we started to expand on what combination was. So combination was 2 or more substances react and produce one. Decomposition is simply the opposite. So it's one substance breaking down to form 2 or more. So if you started your 13 to 17 at all, and you were trying to scope out the combinations, what would we look for relative to the arrow on those combinations?
One on the right.
One on the right. These are obviously going to all be decomposition because they have one on the left. And there's none of these other 5 that we're learning are going to do that. So if you want to start your 13 to 17 and start identifying, everything with 1 on the left is a decomposition. Everything with 1 on the right is a combination, and you can start to lay the groundwork for that 13 to 17 assignment, which if done in pieces is fairly harmless, but if done in a big wad is quite lengthy. 8 is heat. A lot of times to break things down for number 8, we need heat. Side notes that may or may not ever appear on quizzes, but definitely don't appear on the next quiz, so maybe at chapter end or something. If I ask you for like an abbreviated way to write a decomposition, it would be something like that, becoming A plus Z. I don't know if that's coming or not. Heat definitely is going to continue to be a question. I have a note on here that metal carbonates and hydrogen carbonates will produce CO2s. Anybody in the room remember carbonate as an ion memory? What carbonate was about? CO memory. Carbonate to CO3. So if you have something with CO3s, you tend to get out CO2s. The carbonates tend to produce CO2s in the end. You also get a lot of oxygen gases produced by this. So if you look behind me, this one is doing some oxygen gas. Decompositions sometimes are giving off those gases. Thanks for breaking down. But those aren't quiz questions, that's just information that was in the reading that maybe makes like a chapter test, but it's not going to be day by day. Questioning all about that new-ish top 8, scoring it up. Then we're recycling a bunch of old questions. So the 2 main parts we have is the reactants, or the substances that interact with each other, and they're on the left in the equation. I said I'd be a little bit picky about that phrase, in the equation, on this one, so if you don't see in the equation, let's take off a half for that one. Products are the substances formed. Those are on the right in the equations, but since I already nagged you about the in the equations once, I'm not going to take a half point off again. We'll just take that single half point for the one part if you skipped it completely. If you said in the equation once, it's sort of implied for the other one. So as long as you say in the equation once, we're good. We'll make that a half point issue for now. Catalyst, something like increases the rate of the reaction and gets recovered unchanged at the end, or speeds up the reaction, recovered unchanged at the end. 2 half points there, one about the speed and one about the unchanged at the end. The separator symbols, arrows, separate reactants from products. The plus separates reactants from other reactants and products from other products. G for gas, L for liquid, S for solid, AQ for aqueous solution. Don't just say aqueous, that'd be half the answer. Aqueous solution is the whole answer. Triangle for 22 is heat. Symbol above that is that a catalyst is needed. The 6 guidelines are: 1, write correct formulas for reactants and products. 2, pick an element to balance. 3, balance the polyatomics. 4, you balance the H's and the O's. 5, you make the coefficients the simplest whole number ratio, and then you check it, and then I might as well pause there. Anything up to 29 to run by me. Then new-ish questions that were out of yesterday's video. Oxygen for number 30 is the key element. Also 31, that's known as burning instead of combustion. A base is a water plus a metal oxide. If they say water plus and then a funny thing, I'll go half, because you got half the adding problem right for a day. Salts or metals plus non-metals. If you got like half of that right, I'll give you half a point to be nice. Oxyacids or waters plus non-metal oxides. And again, if you got one of those 2 words, I'll give you half of the point of that answer. So I need to run back to 34. So we can give those back to their owners. 9, 8 is what's up next.
If I could, I would have given you 34.
34.
Yeah, you just got the half one off.
Throw it away.
14. Because you're going to say inside the equation.
Of the equation.
That'll work. Of the equation will work instead of in the equation. Yeah, I can go with that. That's okay. Next read up is a 9.8. 9.8, if it's 2026 people that I'm talking to, which is all the people I'd be talking to now, you have a study guide for that I gave out before, or by email, like when this all broke loose. So you have a 9.8 prep sheet. If you're hearing this in the future beyond 2026, great, the videos have continued to serve their purpose. But the next read up, 9.8, the top question is now going to be a 9-point question instead of a 7. So it'll say name the 5 types of reaction, which we did. Give an explanation of 3 of them, because when you read 9.8, there's going to be a 3rd type added on. And then number 8 lumps in there. I asked what's often needed in the reaction from 9.7. So somewhere in the area of decomposition, you would write heat. Then 9.8 has one other fill-in question that has to do with one of these other reactions that we're going to read. And then I trim off some questions. It's down to 21. So trim. We are skipping down to the 6 guidelines. So all that stuff, name and describe the parts and the catalysts and the G's and the triangles and the stuff, that's all gone. But from 24 down, that all stays. The 6 guidelines, the key element, what else it's called, base, salt, oxyacid, that stuff is all going to stay there, but slight trim from 34 to 21. Save us some bother there. It's good news. Question about that?
So is it just one new thing?
There's one new reaction with one other fill-in
Okay.
follow-up point. Something else about that. Homework life from this is doing 1J as well as 9. 9 is represented basically by what's behind me. 9 has no equations you have to write yourself. Hooray. The only ones you had to write yourself were numbers 6 and 7. So those were less fun than anything else you've done so far in those 2 problems. The other thing I will continue to heavily endorse is that 13 through 17, don't wait until you're doing the whole thing in a wad. I would do bits and pieces of 13 to 17. Everything that has one element and an arrow, I would just write down combination, and while I'm there, I'd balance. But that's, you do your own pacing, that's my best advice. So let's balance this thing. We'll do the 3 new examples, and then we had an email request to show 4D, and I'm pretty sure I know what the issue is going to be with 4D, and it's going to be no fault of our student requester. It's going to be the fault of whoever owned the book before her. But for this one, we want to pick an element to balance that isn't H or O. So
NA.
NA works for me. So NA has 2 here, so to fix this NA,
Put 2 there.
we put a 2 in front, and when we do that 2, that means we have 2 NAs, but we increased our hydrogen count also to 2, carbon to 2, and oxygen
6.
to 6, because 2 times 3 makes 6. So sodium's, I'm liking that. Then we pick a different element that's not O's or H's.
So C.
So all we have is C's. C count here,
2.
we just said 2. C count
2.
over here is 2. So C's, naturally, we just fixed it by luck. Then either H's or O's. I would probably do the H's, because the O's is going to take a little more math. So I think I'd fix the H's and hope that fixing the H's just like fixed
But the
everything.
H is already fixed though.
The H is already fixed. So H has 2. H has 2. O's we already said were 6.
And we have.
And we have 3 plus 2 plus 1 has 6. And that is a win. You good with that strategy?
Yep.
So next one up is my favorite one I've ever done yet for any example. Why is this my favorite one I've ever done with you?
It's already balanced.
It's already balanced.
It's done.
So all you would need to do is mark somehow, like write the equation and put some checks on everything, so I know that you checked it and didn't just like take a pass on it, or draw one big check through the whole thing, or write already balanced, or somehow signify with writing something with your own hand that that's already a win. So that was outstanding. This one will be a quick fix too.
2 with 2 on the left and then 2 with the mercury.
2 on the left and 2 with the mercury. The only thing out of whack is oxygen with 2. The only way to fix that's with a 2.
And then,
And when you fix the oxygens, you accidentally mess up the hydrogens, which were okay.
but now
And
there's.
now we just chase it down with another 2, and then we're good on those. Then our request in on 4D was why something wasn't working. So when I look in my book at 4D, the issue is that the original printing of this book has a flaw, and we need to check to see if our previous owner of the book has fixed the flaw. And if they didn't, then it's curtains. So the flaw is right here on 4D. There needs to be a 2 there to make that formula make sense. My book has it penciled in by me too. On 4D, does your book have a
Yeah.
penciled in too?
Yeah, my book was
Did it
penciled
have
in.
penciled in? Okay, so if you don't have the penciled in too, that's curtains. So I'm guessing that might be the issue. It needs the 2 to balance charges, because sulfate has a charge of 2. This iron has a charge of 3, which iron is one of those multiple ones, but we can tell that from over here, because OH had a charge of 1, and there's 3 of them. So that iron has a charge of 3. So this iron, it's the same iron, it has a charge of 3. So charge of 3, charge of 2, we need those subscripts on there. So the biggest thing I warned you about before you did 4 or 6 and 7 is a lot of times if you have to write the formulas, you do it wrong. And visual aid on this, these people authored a chemistry book and they wrote the formulas wrong. So if you're having trouble balancing something, sometimes the formulas are wrong, and that was maybe an issue there. But to balance this, like we were doing before, pick an element. It's not O's or H's.
The iron.
I'd go irons.
2.
So iron had a 2.
2 of the left.
That means a 2. So I just fixed my irons up. Then the advice is, if you have a polyatomic that didn't change, fix that. By which we mean SO4s. So SO4 had 3. So this SO4
That's 3.
has 3. And those are good. Then
Hydrogen.
H's or O's, you know, it's a toss-up. Everything here For hydrogens, seems to be an even number, so maybe just do that. That might be easier to do, but this hydrogen count
3.
again?
Or there's a 2 on that left, right?
Yeah.
Okay.
Oh,
So 6.
6. 2 groups of 3, there's 6 H's.
So there's 12.
So that's 6 more H's. Because 3 times 2 is 6. So 6 and 6, we have 12 H's over here.
So then we have to put the 6 with that H.
So we need a 6 with that H, and now we have 12 H's over there, and the H's got all balanced. And then we hope that the O work. O count for this
2.
6.
is 6, because again, 3 times 2, and that all goes together like distributing kind of stuff. So there's 6 O's there. We already balanced the SO4 O's, so we don't need to recount
So we're
those.
good.
So we're good. We have 6 new O's over here, 6 new O's over there, but like the SO4 package, it's already been handled, and we're a win on that. My guess is the request from home, which I didn't read in great detail what the request even was, it was just something about 4B. I bet the previous owner of that person's book probably didn't fix their 2, so they should look them up and add them to their list, because it's the person who made a request that I know keeps lists. They don't like Lavoisier, they don't like some geometry historical people, so they can, whoever previously owned that chemistry book could just go right on that,
All right. Well,
Right
I
on
have
that-
a 50-50 shot of guessing
right
who
on
this
that,
is.
that time machine
I feel
hit,
like we know.
that time machine hit list, they can travel.
I feel like
and
it's
go
somebody
get
in the
that.
front row on the right side.
It could be somebody that does sit in the front row. To my left, you're right. Yeah,
I feel like
they have some people from their past that they're not pleased with. So we'll see. That the book owner might be on that list. Anybody, any kind of other questions about balancing equations or what's up with chapter 9?